Let's take a look at systems of linear equations. System of linear equations have two or more equations. It really all depends on the amount of variables that you are looking for. We are looking for a system of equations that have two variables, so I have an example right here. They can be solved either by graphing, by substitution, or by addition method. Today I want to show you how to solve by substitution method. Now when we're solving those systems of linear equations, usually our solution comes in form of an ordered pair x comma y. So that happens real quick is if you have two lines, when they intersect with each other, that would be your solution, and this is in form of an ordered pair x comma y. Now this solution has to make both of these equations a true statement. If it doesn't work for one, then it is not a solution. Now something else can happen when you solve these linear systems. What can happen, it's better to show you graphically, if you have two lines and they do not intersect at all, they are parallel. If this is the case, if you have parallel lines, they do not intersect, so that would mean you have no solution here. A third case you could come across with, if you have two equations that look different, but however, when you graph them, you will see they are exactly identical. They just look different. Those are equivalent equations, but the graph is the same. When that happens, the lines coincide. It's called coinciding, and you have infinitely many solutions. Of course, the most common one is actually where the lines intersect and you get some kind of ordered pair, but be careful. Sometimes you have no solution, and sometimes you have infinitely many solutions. So let's go back to this problem. We want to solve this by substitution method. When you solve by substitution method, one of the variables always has to be isolated. So it either should say y equals or it will say x equals. In this case, this setup is beautiful. We already have y equals. Now we can just make this name proud, and we can go ahead and we can substitute. We are substituting, we're replacing the y with x plus 2. Because, why do we do this? We can only solve an equation with one variable. So we try to change our equation into one variable. 3x stays the same, minus 2 times y. However, y is being substituted with what? X plus 2. And now finish up equals negative 5. So this is our new equation, and you can clearly see it has only one variable. Now we solve this equation by our conventional solving equation rules. 3x, we need to clear the parentheses and distribute the 2, but don't forget this is a minus 2, so we can just look at it as negative 2 times x, which is minus 2x, and negative 2 times positive 2 is negative 4, equals negative 5. We cleared the parentheses, combine like terms. Which ones are like? 3x minus 2x. Beautiful. 3 minus 2 is 1x. Minus 4 equals negative 5. The only step left is to add 4 to both sides, which leaves us with x equals negative 5 plus 4 is a negative 1. Now do not stop here. Since we have a value for x, we also now need to find the corresponding value for y. And how do we do this? We go ahead and we substitute and we're substitute into the equation that says y equals, we're replacing the x with -1, -1 plus 2. Beautiful. -1 plus 2 is indeed 1. So we have found the point where the lines intersect, and we want to write this as an ordered pair. The last step is write it as an ordered pair. X comes first, -1, 1. Done you are. Let's solve this system of linear equation by substitution method. For substitution method, one of the variables has to be isolated. That needs to be our first step. So one of the variables needs to look like x equals or y equals. You have to decide which one you think is the easier one to rearrange. Here we don't have the setup. So one of these equations has to be rearranged. And if it is me who's doing the problem, I would go with the first equation. And you want to look for the variables being by itself. In other words, the coefficient is 1. So the only place where I see a coefficient of 1 is right here, minus y, this term. So I want to solve for y, the first equation. That means the first step is to subtract a 2x from both sides. Let me continue down here. Be careful. This one says -y. -y equals, let me write the x term first, -2x minus 1. Am I interested in -y? No. You have to change this to +y by dividing by -1. All three terms. This becomes y equals, negative divided by negative is a +2x plus 1. So now I have accomplished my goal of isolating one of these two variables for either, in this case, y. What do I do with it? I'm going to substitute the y in the second equation with 2x plus 1. Why do I do this? To get an equation with just one variable. So now I'm copying the second equation, 5x plus 4, but the y is being replaced with 2x plus 1, and that is equal to 17. So this is now the equation I have to solve by clearing the parentheses first. 5x plus 4 times 2 is 8x, 4 times 1 is 4, equals 17. 5x plus 8x, combined like terms, is 13x, plus 4 equals 17. Subtract 4, because we want to solve for x, and look how beautiful this is here. 17 minus 4 is 13. Divide by 13. X equals 1. Beautiful. Now we just have to find y. How do we do that? We're going to substitute again the x equals 1, and you substitute it into the equation that you have solved for y. That makes it easier. Y equals 2 times x is 1, plus 1. 2 plus 1 is indeed 3. Y is equal to 3. Our ordered pair, in this case, again, this is a case where the lines do intersect, and the ordered pair would be 1, 3. Just like so. Here we have another systems of linear equations, so let's solve this one by substitution as well. As you can see, we do not have to isolate here because our first equation already says y equals, so the setup is perfect. All we need to do here is substitute. we're substituting, we're replacing the y in the second equation with 2x minus 5. So let's do this. 8x minus 4 times y. Y is, in this case, 2x minus 5. We're substituting the y, and then we continue on with the second equation, and this is equal to 20. Solve this equation, distribute, and clear the parentheses. 8x minus 4 times 2 is minus 8x, and we have a minus 4 times a negative 5, which is a negative 20, and that is equal, oops, that is not a negative 20, that is a positive 20. Negative 4 times negative 5 again, negative 4 times negative 5, positive 20, and that is equal to 20. So let's see what we can do. We combine like terms. 8x minus 8x, no worries. Yes, indeed, they do cancel out. That does happen sometimes. And what we are left with here in this particular problem is 20 equals 20. Now here on the other side, on the right-hand side here, are our three cases. We don't have a variable, so we're not solving for x and y in this case. They do not intersect at just one point. What happens is when the left-hand side is equal to the right-hand side, basically an identity, which means this would be our third case here, and we have infinitely many solutions. So if your variables all cancel out, and no worries, this does happen, then you have infinitely many solutions if you have an identity, what you're left with, if the left-hand side is equal to the right-hand side. That's the case here, which means the lines, if we were to graph that, would be exactly identical. They do coincide. They may not look the same, but if you solve this second one for y, you will see they reducing, and it actually will be exactly the same as the top one. Infinitely many solutions.